Okay, this video is all about the momentum and impulse grade 12 physical sciences. So we'll cover definitions, formulas on how to apply them, and principles of momentum and impulse. It's your boy Master929. Welcome to my YouTube channel. So if it's your first time or joining this family of mastering topics, please hit that button below to subscribe. And if you're already one of us, please like this video. Hope you will enjoy this video. So what is momentum? Momentum is the product of the mass and the velocity of the object, and it is given by this formula, where P is the momentum and M is the mass and V is the velocity of the object. And whenever you are using this formula, make sure when you substitute, mass is measured with kg and V is measured with meter per second. If not so, make sure you convert those measurements. And you must even know that momentum is a vector. So what is a vector? A vector is a physical quantity with both magnitude and the direction. So as for the direction in momentum, direction is indicated by signs. You see, so and each and every time you choose the sign, make sure you choose a positive as well. Choose a positive as the direction, as a direction in the question. Then I'm sure you choose all the movement in an opposite direction as well as negative. So now let's try to answer that question. So that question, Aaron, a car is traveling at 60 km per hour, and if the mass of the car is 250 kg, calculate the momentum of the car. So you can know that mass is 250 kg, then velocity is 60 km per hour. You see, so now H, yeah, H. So now re gona bona gore velocity ya rena ga e measure ka meter per second. So really so re ka se gone go e faka mo leng V, but 250 kg we can sub it here because it is in a correct measurement. So now let's try to convert this 60 km per hour into a meter per second. So we are going to take that 60, so we are going to say 2, it's question 2, right? So we'll go 60 divided by 3, is 3, let me see, 3,6. We're going to divide it by 3,6, and we're going to answer 16,67 meter per second. So we want to know velocity now in incorrect measurement. So now we are going to sub our velocity and mass into this formula. So now we are going to introduce this formula of calculating momentum. Then where is mass? We are going to substitute mass 250. Then where is V? We're going to sub this one. Then we are going to don't forget this thing, I'm my calculator. So it's about 250 multiplied by 16,67. Then answer 4,166. 4,167. 67, yeah, 5 kg meter per second. So check the units of calculator. I mean give units ja momentum. So how about the direction? Then direction or in the direction of the motion of the motion. Why direction of the motion? Remember, really always choose a direction as positive in your question. So our question, a car is traveling at 60 km per second. So meaning if this thing answer no is positive, so that is still in what? In the direction of the motion. I get change, but remember negative. Another story opposite. In the direction of the opposite direction, in the opposite direction of the motion. You see, but now answer is positive, so in the direction of the motion. So sometimes the motion of the object may changes. So it can change again. The motion of the object can change by what? By the velocity. And whenever the velocity changes, the momentum will also changes, since it depends on what? On the velocity. So now are checking what if the momentum will change, re tlo calculate wow. So now let's talk about what? Change in momentum. So change in momentum in a formula, which is change in momentum is equal to P final minus P initial. So sometimes we can just say mvf minus mvi. Right, so mv stands for P, so that is why more replace P ka the mv. So now P final, this P final give momentum wa final, then we give momentum wa initial. So now let's try to answer the question in the screen so that re kgone go bona gore this formula re apply jwang re tswile mo questioning. So question Erin, a tennis player serves a tennis ball towards his opponent. The ball moves through the air with the momentum of 11 kg per second east, and the opponent hits the ball back in the opposite direction, and the momentum of the ball changes to 8 kg per second west. Then number 1, but calculate the change in momentum of the tennis ball. So barbanaka change in what? Change in momentum. So now we are going to introduce this formula. Right, then pf minus pi. And as for the direction, we are going to choose east. We are going to choose east as what? As positive, because momentum are now to make our ball are not to me go east. Then be ya go in an opposite direction, we are going to west. So west is it over negative. So now let's try to substitute. So the momentum wa final goal, momentum wa final ke 8 8 over negative 8. Why ever negative 8? Because really west again negative. So value ya 8 that raise up with the negative side. So then there are minus of this formula. Then initial momentum one again 11 kg per second. You see, then we do this calculator. Then we do final answer. Then we negative 19. So operator momentum is a what? Is a vector. Is a vector, and then vector again is a physical quantity that has both magnitude and the direction. So no sooner should that direction, and at our negative the direct error west as for this question, because the direct east as what? As positive. Therefore our final answer now again final answer is 19 kg meter per second. Take your units momentum. Then for as for direction raring west. Why west? West is again get this negative. Then this negative rafagala west, because so west again get negative. We choose east as what? As positive. You see? So this is how we apply this formula. A question. So now let's jump to Newton's second law in terms of momentum. So how do we state this law? So we state this law like this. The net force acts on an object is equal to the rate of change in momentum of the object in the direction of the net force, and it is given by this formula. F net is equal to change in momentum divided by changing time. So each and every time we go Newton's second law in terms of momentum, you have to think about this formula. So and make sure each and every time we an exam room or a physical science paper, you know how to state this law in terms of what? In terms of momentum, or Newton's second law in terms of momentum. So now let's try to answer the question so that how do we apply this formula. So now question A, a 5 kg model rocket is launched from rest and reaches a velocity of 12 meters per second in 3 seconds. So you can see gore mo go boleleng change e thomme e le go 0, therefore jig yona ke is plug ke bokae ke 12 ke 12 what ke 12 meter per second. So e change ka time ya bokae ya 3 seconds. So but this is a result of the upward force of the exhaust gases. So therefore this again this rocket ya go godimo. So the direction of the question is what? The direction of the question is upward. So we are going to take upward as what? As positive. Remember, we are positive, sign here positive, each year again, each the direction of what? The direction of the question. And the direction of the question now again get upward. So now question number one, but calculate the net force experienced by the rocket. So but when you got the net force and ka momentum, each and every time like a net force over net force rekraga formula ya Newton second law in terms of what? In terms of momentum. So now roto this formula will solve this question. But formula it's about changing time and changing momentum. But for now it's about changing time, which is 3 seconds. Then I'm changing momentum. So Lama Thomas not changing momentum. So how are we going to get that? So now let's try to find changing momentum first. Then the other formula your graph changing momentum is PF minus PI or MVI minus MVF minus MVI. So now let's try to substitute here. So we check more question. We are not given the momentum, but we are given masses and and the velocities. So now let's try to solve. What is our mass? Mass is 5 kg. Is 5. We are going to use this formula because but we are given what? Masses and the velocities, not the momentums. So now then velocity final again. Velocity final is what? Is 12. Is 12. It's 12. Why 12? Why 12 give velocity final? Because this thing to me is 0. Then yeah, right after 3 seconds you have 12. So that's what 12 velocity final. Then what is the final velocity? Initial velocity. Initial velocity is 0 because this thing into my wing it was launched from rest. Rest. So that is what I 0. Therefore, ambition changing momentum like an at least 60 kg meter per second. Then this one final answer may give a positive. I guess since the positive show the direction. So positive error upward. Why upward? Because regulate matomo the direction of the question again get upward and regulated are always reject the direction of the question as what is positive. So final answer negative positive, so that now Roger the final answer in the direction of what? Upward direction. So now let's introduce this formula. Again Fnet. So this formula changing time. Then now we have changing momentum is 60. Then divided by time is what? Time is 3 seconds. So then Roger distance on my calculator, until 20 newtons. Then 20 newtons upwards. Why upwards? Because force here, this thing is a force. That's not the force again. So the force. So force direction now guy upwards. Right? So and no one because we reason now wire upwards. Reason now. So now force measure again newtons. I want so but later wire get upward get choose again direction this Fnet is upward because always changing momentum is always in the direction of the net force. So direction here changing momentum, get direction here Fnet. Always know that or change in momentum is always in the direction of what? Of the net force. So now final answer again 20 newtons upwards. So now let's jump to impulse. So what is impulse? Impulse is the product of the resultant force acting on an object and the time the resultant force acts on an object, and it is given by this formula. So as you can see, this formula is much related to that formula of Newton's second law in terms of momentum. Yes, it is, because impulse is related to changing momentum. But now we are not going to talk much more about the impulse. So probably like I to answer exam type questions. So yeah. So now let's go to law of conservation of momentum. So the object DJ, maybe there are two. So but what is important, let's start on explaining or what is law of conservation of momentum, or how do we state this law. So this law is stated like this: in an isolated system, the total linear momentum is conserved, and it is given by this formula. So this formula no ra gore go tšea di momentum initial tša object j2 o di plus e tlo lekana le go tšea di momentum tša finally tša di object j2. So whenever le gonna solve this thing is okay, law of conservation of momentum. But those that collision so the area mo long gore ke isolated system where the resultant external forces acting on the system is what is zero. So whenever the resultant external forces is zero, we can apply this law, which is law of what, of conservation of momentum. So by example, this thing mara do go ntšha two scenarios. Number one, e gonna be scenarios of collision. So most scenarios of collision, maybe sometimes e gonna be, or mostly even two cars colliding. Red collision two they collide. So whenever collision two collide, or this conservation, this law of conservation of momentum. So this one sometimes mostly barato scenario sa collision. Maybe got to be collision two, but for collision mostly. Number two is explosion. So explosion a gun fires a bullet. Rest a bullet. One. So more with punchy barato like one child, that type of equation. So mostly we practice and make sure we practice this one first before we create all this scenario GDM. Yeah, I might check these scenarios fair. Only scenario GDM body incha, but mostly. And now we get it before we practice our all more law of conservation. Tomagaji to practice the scenarios of these two things, which is collision and explosion. So right place collision will apply this formula, and the right place explosion will apply this formula. So a guy exam fast. Let's more get better. So okay, this thing is collision now. Collision is better. So. I'm not saying we'll do this these two type of scenarios. No, they want to do, but mostly J2J. So now let's jump to elastic and inelastic collision, last part of our video. So whenever we have a collision, it's either that collision ever elastic or ever inelastic collision. So now I will link elastic first. One, elastic collision. So elastic collision rare, the total kinetic energy is conserved. The total kinetic energy is conserved. EK initial is equal to EK final. You see, so what does this formula mean? Formula in our whole the the kinetic energy J initial J object J2 J initial o di plus e tlo kana le go ja di kinetic energy ya di object J2 ja final o di plus. So some ya jona to yang e tlo ka kinetic energy ya final la initial to yang e tlo le kana ya the object J2. So in other words, the total kinetic energy is what is conserved. And we check this thing I saw there law of conservation of momentum. This thing kill kinetic energy. Okay, check this thing kinetic energy as a momentum. So study so now I didn't go elastic, go inelastic, elastic collision. So more inelastic collision, the total kinetic energy is not conserved. The total kinetic energy is not conserved. Sorry. Final. Roger the initial kinetic energy initial total kinetic energy initial. I guess the name the total the kinetic energy J don't already more final. This is F. They don't already more final. So can you spot the difference between? As for elastic collision, the total kinetic energy is what is conserved, and as for inelastic collision, the total kinetic energy is not conserved. So yeah, so guys, this is the end of the video. I hope you have enjoyed the lesson, and if you have any question, please comment. And if it's your first time or joining this family of mastering topics, please hit that button below to subscribe. And guys, please like the video.